So we are given triangle ABC is equilateral if LM is 1, LN 3, and LP 5. Find the area of the shaded region. Okay, we can easily see that the area of this shaded region is the area of the big circle minus that of the small circle. So our aim here, the first thing we have to do is to get the radius of the two circles. So let R be the radius of the small circle. Big R be the radius of the big circle. Let H be the height of the equilateral triangle. So there are some relationship we're going to establish here. So we'll establish that R, that's the radius of the big one, is equal to 2 times the radius of the small one. And again, we're going to establish that the height of the equilateral triangle is equal to the sum of the radii, that's R plus R, which is R plus 2R, that is 3R. And finally, we are going to establish that the height is the same as the sum of these segments, that H is equal to LM plus LN plus LP. So with that, we've solved the equation already, because if we use all this relationship, we can see that the height is this 3R, and the height is also LM plus LN plus LP. So we can easily see that. Maybe let's just solve the equation after I will prove how I got these formulas. So we can see that H is now the sum of these, which is 1 plus 3 plus 5. And also the H is the same as 3R. So we can easily see that R, this is 9, 3R, so R is 3. As the small r is 3, radius of the small circle is 3. Therefore, the radius of this big one is 2 times 3, which is 6. Therefore, the area we are looking for, area shaded, is now pi r squared minus pi r squared, which is pi 6 squared minus pi 3 squared. So as you can see, this should be 27 pi. Yes, our answer is B. So that's the answer. So let me now prove all this. I'll use 2 diagrams in solving this. Let me use this one first. So if we add some auxiliary lines, so if you take this as the center of this circle, yes, as you can see from that, let's call it O. So you can see that AO is big R, that's radius of this big circle. Yes. And O, maybe, okay, let's call OPMN. Okay, let's call here Q. And you can see that OQ is the radius of this small circle. So if we call, this line acts as a tangent line, so this is 90. So this is small r. And this is big R, that's OA is big R. So have you seen that the height, this height, which is the same as the height of the triangle, is now small r plus big R. So I've established this. So let's now get how big R is the same as 2 times small r. So since this is an equilateral triangle, this is an inscribed circle. And you know, for our basic geometry, if you want to inscribe a circle in a triangle, we bisect 2 angles. So the point of intersection is now the center of the circle. So I'm saying that, assuming if I bisect these 2 angles, you know, the interior angle is 6, is an equilateral triangle. So each of this is 30. 30. This is also 30. 30. So have you seen it? So the point of intersection of the angle bisector becomes the center of the circle. So we now have a 30, 60, 90 triangle. So since this is R, the one opposite 60 degrees will be R times root 3. So R root 3. And the one opposite 90 degrees is 2 times R, small r. So have you seen it now? This is also the radius of this big circle. The radius of the big circle is the same as 2 times the radius of the small circle. So we've established this. So let's now establish this. This is angle 90, 90, 90. So we can relate it with the triangle, because we know that area of a triangle is half base times height. And we know that the height is always perpendicular to the base. So if we join, we're going to form, I'm looking at this triangle ABC. If we join A to L, L to C, B to C, we'll form 3 triangles inside this triangle. So let's join. So we've joined that. So if we call side of this triangle, let's call it A. You know, each of them that is an equilateral triangle, so they are all A. Each side is A. So we can see that the area of the triangle, area of this triangle is half the base is A and the height is H. So let's again, you can see that the area of this triangle is also equal to the sum of this area of triangle LAC plus area of triangle LAB and finally area of triangle LBC. Yes, so it's either you use half base times height, knowing the height of this triangle, or that you use the sum of these 3 areas of this, because as you can see, this is a triangle with height Ln. This is also a triangle with height Lm. And this is finally the third one with height Lp. So we can equate this to this. So this is half A times H. This is also half base. The base is A and the height is Ln plus half the base is A, that's LAB. Okay, the height is Lm, and finally half A times LP. So have you seen it now? What is common? We have half a in both sides, so half a, half a, half a. So we are left with h is equal to ln plus lm plus lp. So that's the height of this triangle. And I told you, using the height as from the former diagram, see the height is perpendicular to the base. So I've proved that. So that's how we got the formula that we use in solving this. So it's a very nice and tricky question. Thank you very much.